of the, less than 3% of the total electricity supply in India. On the second stage, which is extremely important under Indian conditions, as you would have noticed, the aim is to recycle the spent fuel after reprocessing and do that in fast reactors, fast breeder reactors, because by so doing, you can get 40-50 times more energy out of same uranium, which is very important for us. So India had set on path of development of fast reactors, and today, in fact, the 500 megawatt prototype fast breeder reactor is in a very advanced stage of construction, and actually that's one thing which makes particularly me very proud, that although fast reactors were being practiced by many countries, including United States, France, UK, and others, today we have the distinction that when this 500 megawatt PFBR gets completed, and that should be a matter of maybe 1.5 years or so from now, this will be the second largest fast breeder reactor, operating fast breeder reactor in the world. The 600 megawatt BN 600 operating in Russia, and this would be the next largest reactor. So we are kind of globally advanced at this point of time in fast breeder reactor technology, and that is the key to maximize the energy potential or the power potential from the resources we have. We can in fact push it to 300 gigawatts if you look at it as pure uranium, but then you add that, you can go up to even 500 gigawatts. And that will pave the way, that will set the base, a large enough base for large scale utilization of thorium. And thorium also, all the basic development is true for the entire fuel cycle. The front-end fuel cycle, the reactor design, construction, and also the back-end fuel cycle to some extent. This entire fuel cycle development has been done. We have actually a small reactor operating in Kalpakam. It's not a power producer, it's an experimental reactor. But a larger 300 megawatt electric reactor, advanced heavy water reactor, is under development. And in fact, it's ready for deployment. It's only a matter of time. They're making a project report ready for government sanction, and then one would be able to deploy that reactor. I'll come back to this because there is a thorium connotation which is important, but there is also a safety connotation. It is advanced in both aspects, and I'll talk about that. So the short point I'm making is that India is technologically self-reliant, and it's not as if there are in fact elements in this has been, it's not what I am saying, it has been said by others, including US. Siegfried Hecker, in testimony in Congressional Committee, has in fact gone on record to say that there are elements in Indian program where the US can benefit. India, of course, can benefit a lot from US program. So there is that mutual interest in terms of collaboration. So the question is asked, if all that is true, then where was the need for this big effort about opening up of civil nuclear cooperation? And the answer is in this sequence which I will show. This projected requirement, the black line at the top, is actually a calculation for the India's energy or electricity requirements, the growth in that electricity requirement. And this is what it goes up to by the year 2050. It goes up to 5,000 kilowatt hour per capita. Cumulatively, it will mean something like 1,300 or 1,400 gigawatts of electricity production. Now, if you start filling it with whatever energy programs that you can mobilize, and this is an optimistic summation, we looked at what can be done by hydro, coal, non-conventional, including the domestic three-stage program which I just described. You add that, and I call it an optimistic summation, which itself may be a questionable thing, but even if you do that, you find a gap. There is that unfilled gap, which is the deficit. There is deficit even today, and India is importing energy for electricity. We are importing energy for transportation, that's a larger one, but we are also importing energy for electricity production. And this will keep growing with time. And in 2050, this projected gap is equivalent of 400 gigawatts in terms of coal import. Because you have to bridge that by import of energy. Seen in terms of coal, it amounts to something like 1.6 billion tons of coal annually, which is just like a huge. And that's the importance of developing civil nuclear cooperation. For example, there is a delay now, but this was worked out when I was working on this development of civil nuclear cooperation. For example, if the time period 2012 to 2020, one is able to install something like 40,000 gigawatts through light water reactor import, and that's represented by that yellow band. Then the spent fuel arising from that, because the condition is that you set up a reactor from through international cooperation, there has to be matching. All the requirement of fuel for that has to be met from international sources. And so the spent fuel arising from these reactors can be again reprocessed and recycled because we have that technology. And then set up additional capacity, as you can see in this olive colored band. And if we implement the program right, there is full potential to bridge this deficit without having to import any additional energy. And that is the core objective with which this international civil nuclear cooperation has been developed. There is some delay, so now bridging this by 2050 may not be possible, but it will get, suppose in 5-6 years delay, it will get bridged by that much additional time. So this is the program in general. Now there are of course challenges. There are challenges in terms of, and I'm now talking about the challenges from an international perspective. There are of course challenges within the country, but we should also recognize the global perspective. And in India, we use the fuel in the recycle mode, closed fuel cycle mode. But internationally, it's not so. For example, in US policy is to use fuel in open cycle mode. Spent fuel which comes out is actually considered a waste. Then you think of burning it. You must have seen everything that will happen and you come out and it seems to be a non-starter. So it's a management of spent fuel in open cycle, in my view, is an unresolved issue. There are of course serious concerns on proliferation, and so we have all kinds of regimes and barriers to growth of nuclear energy or transfer of nuclear technology. And I'm sure you are all too well aware of politics that goes around. And then post-Fukushima, there is this re-emergence of safety concerns. If you see in objective terms, nuclear reactors or nuclear energy is still the safest of all energy, even after Fukushima. You ask a question in terms of number of fatalities or number of or some quantification of health concern per kilowatt hour energy produced, and compare different energy forms. In fact, you will come, there is enough literature on that to prove that nuclear energy is the safest. But there are people who show that it is safer even compared to solar. Not many people will appreciate that. But if you see in terms of the total energy cycle, from start from raw materials to and disposal. The risks with nuclear today are this, but that's not what people perceive. People perceive, there is this problem of catastrophe syndrome. Large accident is something which is unexpected. So it's not enough to say that no, this is very rare, the probability is extremely low. So it is safe enough. There is this issue of avoiding large incidents totally, and that I think needs to be answered. And I'll come back to that when I talk about advanced water reactor. So there are different responses being worked out internationally. There is this development of proliferation-resistant advanced reactors and fuel cycles. You must have heard about this Generation 4 Initiative Forum, which is an international program led by United States, which is aimed at doing exactly that. The only thing is, this development is likely to be completed maybe 20 or 30 years from now, not earlier. There is also this question of developing technologies for partitioning and transmutation of actinides, because that's what will make the waste disposal issue a non-issue. When you do recycle, you take care of maybe 95% of the materials, the fertile and fissile material you put back in energy use. But there are these minor actinides which have long life. And so, if you can separate them out and transmute them, either in the nuclear reactors themselves or through specially built transmutation facilities, then in fact you eliminate that problem. And there is, I think, indication that in not too distant a future, such technologies will become available. And finally, of course, develop reactors which are safer in the sense that they provide a certain degree of immunity against large-scale accident. Because I think that's the key safety concern. Now, this is the work which is going on in India. It's actually an integration of population and energy. That product, whether it's high, is more likely. India seems not very bright, but seems slighted. But that's not because the per capita is high, but because the total energy is high. That should be. So there is this little spirit, but it shows the disparity around the world. And if you want to really go to, as I said earlier, like 5,000 kilowatt per capita, translated in number of reactors that we need to build, it could come to something like 3,000 to 4,000 nuclear reactors, which is 10 times the number of reactors available worldwide now. And I think the safety issue has to be seen in that context. We need reactors which can be located anywhere, not necessarily away from population. We need reactors which can be built with modest technological infrastructure. We can't say that we must have a high-tech industry to build, because then that puts limitations in terms of the spread of nuclear. So you need a simple, safe, sustainable, and secure from proliferation, secure from diversion of materials, secure from terrorist attacks, and so on and so forth. You need reactors which would not have any impact in the public domain, and we need systems which won't, nuclear fear, one of it's okay, everything you say you are fine, but what about, are you going to leave issues for the posterity? And that's something